Thank you very much, Lorena. Thank you, everyone. Thank you for assisting here, presence or, and online. For all of you that doesn't know us, Maxam is an explosive service and blasting services and explosive supply company. So our topic into this project was more relating to the field environment, to the explosive and blasting services and techniques. And therefore, all the development that we did and all the implementation were related to the blasting environment and how the outcomes from adaptive new explosive and new technique can improve the downstream in the operation. So here we can see more or less a sketch of how a quarry or a mine can work, and we can divide it. Here, I don't know if I have here. Okay, but it doesn't work. Okay, so we can divide it. At the end, the entire quarry cycle, we can divide it into a step before blasting and after blasting. And the link between both these steps is just the result of the blasting. So every action that we take, every information that we take here on the drilling and blasting and design and the planning will have a significant impact into the digging, hauling, and the comminution processes downstairs. So a small improvement here will have, as I said, significant impact into the downstream in the operation. Our role here in the project, in combination with all the other partners of the project, was to implement blasting services and to develop new explosive techniques, new explosive products and techniques to deploy the right product into the right circumstances with two main goals. One, safety. As we know, safety is one of the most important things in every operation. Safety, we will talk about safety related to vibration, control, and fly rocks. When we are close to a neighborhood or close to any other facility. How can we improve safety? Safety can we improve by adapting, and we are going to talk later about this, to adapting the explosive to the rock, to identify those areas of really weak rock so we can control either the fly rocks or the vibration, but also to have a control of the burden overall on the first row. So as I said, safety is our first goal, and the other one is productivity. If we take care about safety but not productivity, we are not making business here. So the goal of productivity is to adapt also the explosive to the rock in order to obtain, according to the quarry requirements. For example, in this case, the purpose was to have a reduction of fine material and to improve the size uniformity of the material. Yeah, this will come as outcome as increase of material recovery and an energy reduction during the transportation and the grading of the material. So in order to understand why we did or how our purpose or our idea of implementation and development of different products, we had to come to how the quarry system works now, how is the future of quarry environment, and how can we improve it. So as we all know, at least in Europe, every quarry is taking care, or blasting in quarry is related to cartridges or ANFO by bag. Okay, so at the end you are transporting explosive, you have to have a traceability, and you have all the inconvenience of transporting explosive. The future, or how is the future, or is not the future, it's a current situation, is to talk about bulk explosive. Bulk explosive, we have two types of products, emulsions and suspensions. Emulsions, really simple, is a water in oil type. You have a drop of water, it's covered by oil, and then you have a tensioactive product that is an emulsifier to hold this mixture. So at the end, it's like you have a mayonnaise, if you are doing mayonnaise. Okay? For suspensions, it's kind of a similarity, it's like a gelatin. You have a solution of ammonium nitrate into a thick liquid, okay, so you have a saturated solution of ammonium nitrate, you provide a more sticky form with wire gum, and when you have all this mixture that is already almost to be saturated, you add more crystals. So you have kind of the fruit inside of the gelatin. More or less a similarity for you to understand, like this is mayonnaise and the other is a gelatin. Okay, so this different kind of explosive will provide different capabilities, advantages, disadvantages that I'm not gonna go into the details, but for us, the purpose here was to talk or was to implement further the suspension, the water gel. And why? Well, sorry. This is important. Here we are talking about explosive. Here we are talking about matrix. This matrix is not explosive, so you can transport as a non-explosive materials, which is further easier to transport and easier to arrive to any place. Even you can put a facility close to any quarry. Well, I'm not gonna go too much into detail, but regulation are much easier in order to transport. So you are transported a matrix. In order to transfer this matrix into explosive, you had to put what we call hot spot, bubbles of air inside of the matrix, so the combustion of the explosive can go far with a speed enough to be detonated. This hot spot can be introduced via physically, by introducing micro balloons, by doing chemical gassing, by introducing sodium nitrate that will react with the ammonium nitrate and will generate bubbles of nitrogen, or you can do it mechanically by exciting the explosive, so the matrix, so the matrix will catch the air in the moment to be pumped. What is the difference between emulsions? Emulsions only can be gassed via physical or chemical gassing, and suspension can be done by the three methodologies. And this is important because now we are going to talk about mechanical gassing and all the advantages and how they could add advantages into the quarry environment. For that, we had to come back a couple of years where we developed this system in another European project, a SLIM project, where we created some patent. That the idea was, we developed the mechanical gassing set compressive air system. That means we are going to force into the matrix to introduce the gas, the air, and according the more air you were putting, the lower density the matrix you will have, and the opposite. So in this project, we patented this system. Now, thanks to the DigiEcoQuarry, we have created the tools and the loading system and all the assets to implement on site, to make it real. For that, we developed new loading systems, and we implemented we did some implementations into explosives to be adapted to quarry, and all of this we cover it up into the digital environmental to fully digitalize everything and to have a control of our blasting environmental, with the purpose at the end to do a drill to mill, to have information from the very beginning to the drill and to know which one will be the impact into the greening process. In this case, well, it is not. So for that, all the assets and instrument that we developed was to, at the end, to have this kind of system that can vary the density along of the hole. Imagine that this is a hole, this is a PVC hose, but you can see that the color is getting clear according to the more air we are adding into the system. So you can control instantaneously the density of the explosive. And how is the trick? I don't know if I put it here. Here. The trick is to create a foam within the hose, in order to create this foam and to be mixed with the matrix. Okay? Here is where we implemented the most of the time of our project, that is to create the specific instrument or the specific device to be robust enough to be implemented or to be used on site, because we try, like I can tell you, 20 different devices, and we tried into the quarry while we were doing the blast, and many of them we got some issues, many of them we were successfully, But at the end, we came up, and I can show you here. And I will go out because I cannot show this with the simple solution. The simple solution that is a plastic porous diffuser that is really cheap, like it's like cents, that you add into the concentric capillary. Here you have one capillary where the air is going. The other is where the additive that will create the foam have. Okay, and when you mix it up, you will create this foam, and this will be inside of the hose. Here will go the matrix, and then at the end you will have some static mixer that will force the material to be mixed. It's really not really fancy, but I didn't know if in the airport they were gonna take it out. So this is the system. After many tries, we came up with this solution that it was working it worked during the second campaign, and we will talk about this later. And another implementation that we did here is we are creating the foam, and we are putting we are creating the explosive at the end of the hose. You can include also a cross-linker additive, so the explosive will become a semi-solid after 10-20 seconds. So they will avoid for the explosive to go through the cracks. You can see after 10 seconds you can hold in your hand, and if you have a crack, you can see here that explosive will sail the crack. It will not migrate through the crack. So this is an advantage in terms of environmental, so that you don't have leakage of explosive, and also you have a better control of the explosive in terms of fumes as well. So this is the truck. This is our truck that we were using during the project. And what we did was this implementation. Here you can have the truck, you can have the wheel for the pumping system, either here or here, depending on the operation. So the idea is just to put the different sensors here. They are kind of moving around the wheel, and all the capillaries are inside. So the capillary will come here with the hose. So you are able to introduce it or to apply into the quarry. But the system also, in order to know the depth of the hole, because when you are pumping, when there is water into the hole, you had to put the hole into the borehole because of the water, to pump up the water in the meantime that you are pumping the explosive. So for that, we installed also an encoder here to know the length or to know the depth of the hole. We were setting up in the collar the depth, so all the hole that was inside of the hole was counting the depth going down and the depth going up. Okay, so at the end we try to have a control of both the depth and explosive in order to change the density of the explosive. Also, this implementation was done not only for quarry, but also for mining. This kind of a truck for mining, this is what we call augering. Okay, this is an arm that goes away and the explosive goes over there. It's pumping over there. But also the system is similar to the one that we saw. We are adding the foam here, and you have an endless screw that will mix up the explosive. So this solution can work both for mining and quarries and small mines. So depending on the truck, depending on the solution that you need, you can choose one option or the other. So, but this is the importance of this project that help us to develop this kind of solution that is already implemented in many operations. So we talk about the product and about the system, but at the end we want to have everything digitalized. So for that we developed or we implemented and adapted for a quarry different system, the blast design software, the cloud, and the truck, the digitalization of the truck, and the logger, that is an app that you have in your that you can use on site in order to add the actual information of the hole. But for that, very important thing, if you have everything online, you need internet connection. We realized that in this quarry we didn't have internet connection. For that, At the very beginning, we created our own Wi-Fi network. It is a prototype, but could be the initial stages of a different mine where you don't have internet inside of the pit. So this is a kind of a parallel project that we had to implement in order to have a communication within our blast. So very quick, the process. You update, you do the drone flight of your blast, you update it into the software, and you send the holes to the drill. The drill do the operation, and then this information comes back, and you can have both the actual position of the holes and also the characterization of the rock. This characterization was done by UPM. It's a software that they developed, so the system can adapt either our own model or the model that from other companies. In this case, we were trying the UPM. It's a really good job in order to characterize whether there was clay or limestone and cavities within the holes. And we will see later why this is important. So the system, what we'll do, the system or the software will adapt the explosive density according to the rock. Whether the rock is limestone or harder, we will use darker red, that is more with explosive with more density, and clearer is those areas where there were a lot of cavities or fractures. And the green one is like DEQ, spaces within the hole without explosive. This was used for big cavities in order to avoid the excessive pumping of the explosive within the hole. Okay. Well, here is more example, and all the calculations that the system does in order to calculate what is the average density and the cap density. Okay. But what is important, we were adapted the explosive to the rock, but also to the profile. It's not the same that we have a profile with critical burden. So you cannot use the same density. You had to lower the density in order to avoid fly rock. Then we have like a really big toe that maybe you have to increase the density here, but here you have to reduce it in order to avoid all these fly rocks. And also this is a situation that happened in the quarry. And this happened a lot into any operation. Imagine that you are going to pump and suddenly one hole is blocked. What can you do? Normally, you have the drill, you will re-drill, but if you don't, normally they say, okay, let it, and we know that we are going to have a big toe. But we say, okay, wait, we can increase the density to the maximum, to the backward boreholes, and we can increase to the ones next to it in order to overcome all this area and to save the operation, how to say, to don't have all these difficulties after blasting for digging. So as you can see, the capability to vary the density will provide you different opportunities and advantages for your operation. So we have the design, we put it into the blast center, and the other development that we did is to create a twin system, a connectivity between the truck and our device. Why? Because you want to introduce the actual information within the hole, and you want to pump according to the actual information, not with the design. So for that, you could add all this information, and there will be a connectivity. So the truck, the app will own over the truck. So when you start loading, you press loading, you will start loading here, but also you will see this in the screen. You can have both operation, or you can have control in both sides at the same time. But the idea is to have a control over the app, because this information after loading will go to the cloud, and you will have the design and the actual information in real time. So as we say, this is the first campaign. You will see some fly rocks over there. Why? Because we were doing the charging, the loading without considering the information of the rock. And we know that this quarry was kind of a tricky one, because they have a lot of clay within the limestone, a lot of cavity. So you don't have a control where those cavities or weak areas are. You may have this kind of fly rocks that are also, well, could be also related to the confinement of the rock. we tried to do our best according to the information that we had at the time. But the point here was to obtain information to try with different explosive density in order to calibrate the models and to know what to do to the for the next for the second blasting campaign. Here is when we came with the drill to mill process, where we took data, or we tried to combine all the data from the measurement while drilling data from the drill rigs, from Sandvik, our data from information from the fragmentation, and also have a correlation with digging rates from about and also the crushing. In order to develop this or to adapt this design according to the rock and according to the environment. Okay, so this is the one that we saw, but this is now in this second campaign is when we did this explosive adaptation according to the rock characteristics. And you can see now the results. Here. That is a more controlled blast. Okay, and we were blasting according to the rock. We were putting the specific density or the specific energy that we needed to put, and also to control the fry and for both fragmentation and for the downstream processes that we are analyzing in order to check if what the model says is okay with the reality. So this was our contribution in this project.